have this 16 megahertz OCXO, which is an oven-controlled oscillator, or it's an oscillator inside of an insulated, heated enclosure. This one is marked 5 volts, and it requires some ancillary devices in order to make it run properly. Originally thought maybe I could take this $20 10 megahertz OCXO and remove it, and I would be left with the support components that I need. It's not the same size. It is 5 volts, as is this. And so I could, I guess, make some sort of a daughter board and take this off, leaving me with this. Now the pinout's entirely different, but I could take a daughter board and mount it above here and somehow attach this to this support board. So what does support mean? This board, for example, has a bunch of components on it. This is the OCXO. These are all support components. There's 3 main groupings here. There's a 5 volt supply that gets roughly, it's got a reverse protection diode. This diode's backwards, by the way. And it's got some RF filtering, and it goes directly to the OCXO. It's got a regulated voltage section where the 5 volts is taken to a regulator and a regulated voltage is supplied to the OCXO. This particular board has an output filter because this is a pulsed output square wave, and the designer wanted a sine wave. So these are the ancillary components. You don't need this unless you want to modify the output. You do need a supply and a regulated control system. My other choice, I have this board. It was designed as a test board, I guess. It does accept this oscillator perfectly, as well as, I'm thinking, at least 3, maybe 4 other sized OCXOs. So it's a universal board. Let's look at the schematic of it, and it's of course a kit, or at least it's not populated. This board, that's the schematic for this, first of all is supplied with 12 volts, regardless of whether the oscillator is 12 or 5. It has a 12 volt input here, an optional 5 volt regulator, which I would have to use for this, a RF low pass filter here, and it goes directly to the OCXO. This board is set up for 4 different size OCXOs. So in a sort of manner, this thing provides power to the oscillator. That's one of the features. The other thing this board does is take the 12 volts and turn it into either 5 volts or 10 volts regulated voltage here. This is a voltage regulator. So it provides a reference, a regulated voltage of either 10 volts or 5 volts. Then it couples that to a operational amplifier whose output, it's DC coupled, can be varied by this potentiometer. That regulated but variable voltage goes down to the control pins of whichever oscillator is plugged in. Then it has merely a resistor and a capacitor on the output. Now, of course, this capacitor is optional. You could derive the raw output from the OCXO less the capacitor. So this board provides the same functionality as this board, a power supply and a regulated variable reference voltage. I think I'll go ahead and put my oscillator on this board, even though it's going to take a lot more space and provide some functions I don't need or probably won't use. Before I go any further, I should say that this board is available, at least on eBay, under this description. The board's $15, say $20 because of shipping. So the bare board is $20. And it's advertised or described as for testing 10 megahertz time bases. Well, I looked at it and I don't see any reason it can't be operated at 16 megahertz. It is for a bare board. There are suggestions on population. There are board layouts, schematic, parts list. More, all available, but on the seller's page. So you don't have to request any of this stuff. The seller is SCS-CT. He's got a lot of interesting stuff. Go visit his eBay site. He's got a few other boards. So I want to test out this 5-volt reference here. So I installed an LT 1236BCN8-5 because I intend to use a 5-volt OCXO. So I went down here and put in this capacitor. I do not have this 3-terminal regulator installed. So there's a trace, of course, that goes up to here. I installed all of these capacitors in the R7. I put this in. Went ahead and put all the little ceramic or multi-layer capacitors in. And I did install this potentiometer, which is, by the way, a 25-turn potentiometer. Oh, this potentiometer. There's a jack, a space for a jack that connects to the 3 potentiometer terminals. So this is installed, but it's not connected. Here are the 1 filter capacitor, the 5-volt regulator, the 100 ohm resistor. And this is this lead leads to my 6-digit Hewlett-Packard voltmeter. And there is a place to read this right here. And it reads 4.9997. Now it's not the absolute value that matters. It's how much it changes with temperature, input voltage, and so and so. But this is a genuine, I don't know where it's made, but it's not a Chinese knockoff. In fact, the only Chinese knockoff things are this capacitor and this terminal. I ordered the rest of this stuff from Mauser using original part numbers given by the board manufacturer, this SCS. I don't want to take a chance of using a out-of-spec part and then blaming on a bad device or poor design. Because this just isn't a board, but it's a development board, I'm going to have to make a connection between here and here to get this 5 volts to connect to the potentiometer. So I connected the output of my reference to the top of the potentiometer. You have to understand that some OCXOs have their own internal reference. If you're using one of those oscillators with an internal reference, instead of building this whole circuit to generate your reference, you would take the internal reference from the OCXO and connect it to the potentiometer. Now, my oscillator does not contain an internal reference. That's why I don't like the term VREF applying to the control voltage. It doesn't. VREF is a reference voltage generated either externally or internally carried to an external pin on the oscillator. Well, this experimental board recognizes that and provides a little triad here of terminals. 2 of the 3 holes I put a jumper in. See a little jumper there. That jumper connects my external reference to the potentiometer. If the jumper had connected the apex up here to this hole, this would be the VREF coming from the OCXO. So this jumper, in the position it's in, makes this connection. If the jumper were the other way, it would connect this to this. Here it is on the board layout. The potentiometer needs to receive either VREF from this device or VREF from the OCXO. Now, if your oscillator generates a VREF, you don't need to use it. You could use an external reference. Or you could use your internal reference. So a jumper is always connected between here and one of these 2. This designer felt he needed to provide some buffering between the tap on the variable resistor and the reference sent to the oscillator. I believe I've installed everything necessary to get a V adjust out here. Now this will be the voltage sent to the OCXO that is used to vary the output frequency. All right, so I put all this in. I noticed this asterisk, and this is R3. On the bill of materials, R3 is called out separately from 4, 5, and 8, although it's an identical 2.49K. It seems to be optional. Do not install DNI. Has an asterisk there. The only reference I can find anything like that is in the seller's text. The op amp can be configured for a gain of 1 or 2. So I'm going to leave R3 out for the time being. There are two other resistors specified, and they are installed over here, depending on which oscillator you install. Remember, this thing will accept 4 different oscillators. I know you can't see this because it's my bench voltmeter, but with the potentiometer turned fully clockwise, I get 49992 volts DC. And 25 turns later, it's a lot of turns, I can get it down to 0.078. So I proceed to install the rest of the supply, which is just these components necessary to make 5 volts DC. If you're not going to use 5 volt oscillator, you can delete this connection. You can delete this 3-terminal regulator. If you are going to use just 12 volts in a 12 volt oscillator, you need to make a jumper between 12 volts and the OCXO terminal here. If you're going to use a 5 volt oscillator, then you need a 3-terminal regulator, 7805, and you would place a jumper between +5 and OCXO. An inductor, another filter capacitor, a 3-terminal regulator, and a jumper. And I'll be ready, I think, to put the oscillator install the oscillator.